Hello everyone, in this video we are going to learn about GenAI and LangChain. First I will introduce the GenAI in brief and then we will talk about how LangChain can be used in order to make GenAI applications. So let me introduce brief concept of GenAI and how it is related on the block diagram, and then I will be talking about how the LangChain can be utilized in order to make GenAI application. Let's continue on this. So basically when you interact with the chat interface in the chat GPT, right? This is the chat GPT interface that you normally use, or some other like Cloud AI or Gemini, etc. Right? So what it does, it takes up the content in the form of text, image, audio, or maybe a code, and then generates another content. So that is what GenAI. So generation of a content, given a content, is GenAI, how it works, and this is different from how the traditional AI works, right? So what normally you do, you interact with the interface and we give the input on this chat interface and it gives us the output, right? So behind the scene it talks to the LLM and gives us the result. We don't take care, we basically don't worry about how it interact with the backend system. So this is this particular thing I've depicted in this diagram. So basically I tried creating a diagram, make it simpler for you so that you can easily able to understand the LangChain terms and then able to build GenAI application going forward. Okay. So in this diagram, if you look into this, you might be this user who is interacting with the chat interface, and this is the block diagram that I've shown, right? And you are actually looking into the chat interface and you are not aware of this backend API, backend LLM basically. And this is an example I've given for chat GPT, and similarly it applies for basically Anthropic, Gemini, and DeepSeek, whatever interface you use. You get the results on their interfaces, correct? Now, how I can leverage their APIs basically in order to build the application. Suppose you are a developer, right? Now you want to create GenAI application. You might have existing application. You want to add GenAI feature in it, right? Or you want to create an application from scratch, which again and boils down to any new startup in AI. Okay. So how we can do that? So basically each of this LLM, for example, ChatGPT or Cloudy, etc., provides SDK. SDK is nothing but software development kit, which is set of functions wrapped, right? Set of functions wrapped and exposed by REST API call. So what we do normally, we go to the OpenAI website in the documentation, we purchase basically subscription and then create a API token. We make use of that token in order to make REST API call. So in this diagram, if you look into this diagram, you are a developer, you want to create a GenAI application, right? So this is a GenAI application basically on a on a high level block diagram. Obviously it is not showing up jargons like microservices, etc. But ultimately there will be an interface which a user is going to interact with, and there is a backend of that application, and some of that backend piece might be talking to the LLM, right? So in order to talk to the LLM, we might be using the OpenAI, basically REST APIs. We go to the ChatGPT documentation, right? Here we do not see directly the documentation. We can simply write in ChatGPT documentation on the Google, right? So let me just show you ChatGPT docs, okay? So API reference. Now here, if you go into here, you can simply sign up here and go to the API reference. You will be able to see, okay, how I am going to get that SDK. Basically you have to download that one with the help of, like, maybe if you are using Node.js, you can use of npmi packages, right? If you are using Python, you can make use of Python packages in order to get this SDK in your application and then make GenAI application, right? So what I have depicted here, if you want to build a GenAI application directly using OpenAI APIs, you can directly go here and download the SDK, not directly like simply downloading the SDK here. Obviously it was earlier days, but simply if you are using a package manager of a particular language, you can simply use that and then create a GenAI application. So whatever you use as a package is depicted here, OpenAI client SDK, and then you can build up the GenAI application by calling the REST API provided by them. So this is one illustration of how we can build up the GenAI application. So here, what is the difference? You create it. This is the interface and backend is totally controlled by the LLM. Here, basically, we are making use of the REST API exposed by the LLM and then ultimately calling them, correct? and we are also choosing the right model for the right purpose in order to create our GenAI application. Now, similarly, if you look into this, the same diagram, but here, what I'm trying to do, I'm trying to create the GenAI application using Gemini client SDK and trying to call the REST API of the Gemini AI. Everything remains the same. The only thing is that this provider is different from this provider. It has other features apart from LLM responses like parsers or related to vector embeddings, vector database, etc. We will talk about it in the new videos, right? New sessions, so upcoming sessions. But ultimately, the goal of here is interacting with the Gemini or interacting with the AI model to create our GenAI application. Now, what is the challenge here? Like, why we need to move towards LangChain or something agent-based frameworks? Basically, if we do this, obviously we can go ahead, read their documentation, can build it up. But there are some features that might be this is having, which Gemini AI may not be having, right? Features related to utilities like parsers, loaders, splitters, etc. So those features might be specific to specific provider, right? So we need to understand each of their technical jargons to get that things done, right? But sometimes it may happen that the maturity of the feature is less in one of them, and it is more in other, right? So we end up like going individual sites and choosing something. So if we have to like choose other, obviously we have to go towards something open source provider, which is Hugging Face, provide different utilities, correct? So we can do, obviously, it's not mandatory to use LangChain or something. We can do stuff ourselves by creating our own functions which interact with each other, and then maybe utilizing utilities outside of the LLM provider using Hugging Face. But sometimes it's becomes like overhead for us to collate all these things and get things done, right? This is where the frameworks will help. Frameworks basically create their own core utilities and provide you like at your own like documentation easily. So you just have one-stop shop where you can simply make use of their packages and create like formatting, like interact with the LLM or parse the output from the LLM, etc. So there the framework shines, right? So if you look into this, if I move ahead, like move ahead with LangChain intro, so what LangChain is actually giving, so here we are doing individually, right? For an application. So, and then if I have to interact with Gemini AI for something else, like maybe this AI is good in one kind of functionality and this is good in another, right? So how we can make use of LangChain here? Like LangChain framework is basically consist of set of functionalities or capabilities, and where we can simply use the classes provided or the functions provided by LangChain to interact with the LLM provider. We just have to pass in, okay, I want to talk to OpenAI LLM with this model. Then I just have to initialize that constructor and I'm done. Similarly, if I have to talk to Gemini AI model, I have to just provide that particular Gemini AI model and we are done. So that way, we don't have to explicitly understand the documentation of each one of these AI providers, right? We just have to learn one thing, basically use one thing, I would say, and then make use of it to build the GenAI application. Similarly to GenAI, LangChain, we have different frameworks like Llama Index, and popular one like Pydantic AI is also very coming along the line. Who is the like Pydantic is basically the core model, validation model, which is the backbone of Python, backbone of Fast API, right? So that is one thing going on. So exploration you can do, obviously it's not stick to one thing, but LangChain is one thing which is across the ecosystem. It's good to learn here. So what it does, LangChain provides a core package, right, which bundle up the utilities, etc., which bundle up the capabilities, right? Plus it to interact with the LLMs, right? So this is they call it as a integration packages. So if I have to interact with this LLM, right? So one thing is I have to add a dependency of LangChain core, which is ultimate necessary. If we have to interact with the third-party system like LLM, etc., we have to make use of the LangChain provider SDK. Basically, if you have to interact with the OpenAI model or OpenAI LLM, etc., so LangChain dash or underscore in different terminology. Like LangChain SDK comes in Node.js as well as in Python packages, right? Bundle. So different package convention will come across, but ultimately it will be like LangChain underscore OpenAI as a provider package for interacting with the OpenAI. Similarly, LangChain underscore Gemini for Gemini related stuff, Google related stuff. So there are two different API within Gemini. So you may see two different provider for Gemini, right? And then third one is the LangChain underscore AWS to interact with the AWS BedRock. So how the BedRock is different here? So BedRock instead itself is not a model, itself is not a LLM provider. Okay, so BedRock is basically one more layer of abstraction where BedRock says that, okay, instead of you interacting individually with the provider, like instead of LangChain provider interacting explicitly with OpenAI, again there is a challenge, right? I have to interact with OpenAI again. I have to interact with Gemini separately, right? And what AWS BedRock is saying that interact with me with one REST APIs, whatever set of APIs I have exposed, and internally I have the capability to interact with models, different models it supports. Like basically, AWS has a partnership with different LLM providers, and we can go to the AWS console panel and enable those model and provider within AWS BedRock and make use of it to actually enable the BedRock to talk to them. Okay, and then we just have to make use of AWS BedRock API like provider LangChain underscore AWS provider, and then mention that particular model without actually switching the LLM provider. Like here, what if we have to interact with AWS Nova model, I still will be using the AWS provider only. If I have to interact with the Cloudy model LLM provider, I still will be using the AWS provider only, right? So this is what the difference in AWS BedRock versus OpenAI model, Gemini AI model, Anthropic AI model, or other rest of the models, right? So instead of interacting individually with the LangChain provider, we can simply make use of the AWS provider of LangChain to interact with the AWS BedRock. Okay, that's one thing about LangChain. Okay, so more of stuff so is about abstraction. Basically, we don't have to worry about individual documentations and individual understanding, right? But yes, there are some things which are shines to specific to specific LLMs, but that is our call. If we have to build it like a mixture of both, so we can definitely do some functionality. We can do it like we can interact OpenAI with the OpenAI APIs directly. For rest of the functionality like utility stuff, formatting, parsing, prompt, etc., we can make use of the LangChain core. So there is no hard and fast rule that you always have to use the LangChain provider explicitly. You can simply make use of this OpenAI provider directly, like REST API directly, and then other stuff we can make use of LangChain core utilities. Okay, so this is the best of both worlds. So what LangChain comes with, these are the LangChain components. Basically, components is nothing but the functionalities have been divided into different kind of sections, which works for one thing, one kind of feature. Like for example, model IO. Model IO is nothing but model input output. Whatever input content and output content you want to give to the LLM, and then you want to get generated from the LLM. So that is covered under this functionality umbrella. So this is chat models. Basically, if you want to pass chat messages to the LLM and want to expect chat messages from the LLM, so make use of the chat model classes or functions, etc. And if you want to send plain text to the LLM, want expecting a plain text out of the LLM, then go with LLM classes or functions. Basically, prompts are basically if you searching here, like in ChatGPT, if you search for if you search something, example, I want to know about India, right? So India is fixed, like it will give the response about India. Then I have to write, I want to know about any other country, right? So I have to type in explicitly that country name, right? So what if your GenAI application is giving a functionality like in the UI, in the front end, it says that, hey, what do you know, what country, select a country you want to know about, okay? And what the user is selecting, India, from the front end and submit, right? So that India will get into our backend system, and we already have a prompt ready. Like I want to know about placeholder, right? And that placeholder will get replaced with country India. So that is nothing but a content with a placeholder is nothing but a prompt. So it is similar to what you normally do in Python, like using f strings, using string.format in Java. Similarly, in different languages where we put in the placeholder like mustache templates or template engine normally do, right? So this is nothing but the prompt template, but it is very strong. Basically, it gives a dynamism to the prompt instead of a static one. And definitely it gives some context to the LLM, okay, what to do, how to act. Like we can tell to the LLM, right, hey, you are basically a physician or a doctor, you need to recommend suggestions to the patients, right? So, and then basically whatever we enter afterwards, like whatever we ask to the LLM afterwards, so it will respond accordingly, right? So that is how we can make use of the prompts and all. And then we have a retrieval is something related to data, any manipulation of data, reading of a data. Like document loader is nothing but, suppose you want to give a PDF to the chat GPT. Okay, if I go to the chat GPT, so what you normally do if you want to give a PDF to this, there is a option of attach files, right? So it was not earlier in the when it started, right? So here we can attach PDF, etc. But similarly, we can achieve it with the help of document loader. If you want to, like for example, if you want your resume to be rewrite again by the LLM, right? What you normally can do, you can simply upload the resume to the LLM, to the GenAI application. You can make a feature, hey, you can upload your resume into my resume builder. Okay, so with the help of document loader, you can get that PDF uploaded, and then you obviously the PDF may be bigger. In the case of resume, it may be 2 or 3 page, but in case of any more big PDF, like kind of a research PDF, so in that case the PDF might be big. So in that case you may have to use the text splitter. You have to split that up page by page, sentence by sentence, or paragraph by paragraph. There is a strategy of splitting it up, and as well as there are agentic split, as well as there is semantic split, right? Meaningful way of splitting it up. So text splitter help in those. If those text splitter is not which is provided by LangChain is not we can like it is not available, but there are third-party libraries as well which we can make use of as a text splitter as well. So embedding model is nothing but we have the model which is different from the LLM model. LLM model is generating the content from given content, but embedding model is nothing but embedding model. Again, these are all the OpenAI, Gemini, etc. All those LLM providers provide the embedding model as well. Okay, there is 2 type of model. One is content generation model, second is embedding model. Embedding model, what it does, it takes up the content, it converts that content like the textual information into the vector, basically vector which is vector array, right? And the mathematical term which is point some array and then set of numbers. Okay, so this concepts we will understand in the upcoming videos, where it actually we can store those entire text or set of text or a single word, etc. in the form of vector within the store, and the store which stores that vectors are known as vector stores. Okay, so they are specially designed for storing the vectors, or we can have like additional capability in the existing database, like in the PostgreSQL they have PG vector kind of capability where it also allows vectors to be stored. Okay, so vector store will allow that conversion of converted one, basically the converted vectors to be stored. Okay, so, and retrievers are nothing but retrieving that vector information from the vector store. So they are retrievers. Okay, set of functions to retrieve vectors information from the vector store. Okay, so basically this help in actually giving extra context to the LLM. So instead of giving like storing the whole information into the database and then giving it to the LLM, we can simply store it in the form of vector and then make use of the semantic search. Basically, if I want to search for some text which is like semantically matching with whatever is stored in the vector store, we can simply make use of the simple query to get that vector information and then make use of that text and give it to the LLM along with our query. Okay, we will understand this when we understand the RAG with LLM, LangChain, etc. So we'll understand that. Okay, composition is nothing but like GenAI, like this is a very simplest use case that I've shown, asking the question and getting the answer, right? But in the real world, it's not like that. Like it may be like the response from the LLM comes in and we just have to get the response, again have to send that response to the another LLM, right? Or another function, etc. So composition is that way. Okay, so there are tools like, for example, if I want to have a lookup from the website, like for example, if I want to search for something which is not latest, LLM is trained for some time in the past. Okay, it does not know about the recent thing, right? So what we can do, we can make use of a function which simply talks to the website, get that information, and then send it to the LLM, right? So to interact with the outside world, we make use of the tools. Tools are nothing but simple functions. It's provided by the LangChain, which help us actually interact with the outside world. Okay, and agents are basically, you can say, they are again set of functions by LangChain which intelligently choose which intelligently get the output from LLM and then make use of that output in order to decide upon the arguments of a function. What can be the argument of a function? Basically, whatever the response comes from the LLM, it will actually get that data. Like suppose your function has 2 arguments, A and B, and then that A and B is coming from the LLM. So it will simply get that A and B from the LLM response and simply gives us an opportunity to call that function with that A and B. Okay. So what we do, we call that function, and then the response of that function we again can fed to the LLM, or we can get that response directly to the end user. Okay. So that way agents help in actually talking to various system, various integration points with the help of tools. Okay, agents and tools combination basically. We'll learn about it. LangGraph is also came in, where collaboration of agents, or you can say orchestration of agents is easier with the help of LangGraph. Okay. Chains are in the LangChain, as the word says, LangChain. So it says that simply output of one LLM can be fed to the another LLM, and then output of another LLM can fed to the third LLM. So that way we can chain the overall functionality to get the final output. Okay. So all these are functions only that gives us this capability. Additionally is like memory, which again, if we interact with LLM, obviously if we do the chat, there are chat history it maintains, right? So it maintains that chat history with the help of memory functions. We basically use that memory functions to say that, okay, this my chat, this entire chat will make sure that it will be stored, like in the history of that chat will be maintained. And then whenever I send a request to the LLM, it will send the history along with it. And obviously if we keep on sending the history, it may become big at a time. Then we may require some kind of, you can say, trimmers to trim that message and then send it to the LLM, right? And then callbacks are something handlers basically. There are some during the interaction with LLM, so there are states basically. At certain states we want to invoke some handlers, like for example log something, monitoring, etc. So in those cases we can make use of the callbacks. The easier callback is std out some interaction, right? So we can simply attach that handler in the LLM interaction. So this is how the overall LangChain intro that I covered. Obviously, I'm going to cover video on top of writing the individual pieces and making use of the components so that we can make useful application. So stay tuned with me on the upcoming videos. So I hope you enjoyed this video. If you really enjoyed this video, please like, subscribe and comment in the below section. And I will see you in the next video. Thank you so much for watching. Bye.